Problems on palindromes are usually fun to solve, but at the same time, whenever I read that, I have to find out all of the different possible combinations. That usually means the problem will be a little tricky. I think you also feel the same way. Well, this problem is a combination of both. So let's see how we can tackle it. Hello friends, welcome back to my channel. First of all, we'll quickly go over the problem statement and understand the given sample test cases. We will quickly see why a brute force solution is not feasible. And then we are going to find out a way how we can quickly identify these palindromes. We will keep a count and then eventually we will also do a dry run of the code so that you can understand how all of this is actually working in action. Without further ado, let's get started. First of all, let's try to make sure that we are understanding the problem statement correctly. In this problem, you are given a string S and you have to return me the total number of palindromic substrings that can be obtained out of it. Naturally, we first need to understand what do you actually mean by palindromic substring. A palindrome is nothing but a sequence of characters which reads the same when you read it from the front or from the back. For example, if I have the string available race car, then if you read it from the front, you get RACECAR. And when you read it from the back, you again get the same sequence, RACECAR. So this is a palindrome. But what about substrings? So a substring is a sequence that is derived from the original string and it is a sequence of contiguous characters. For example, from this particular string, you can derive a lot of substrings. So you can see that CE is a substring, CEC is a substring, ACE is a substring, all of them are substrings. And you can naturally see that there are so many substrings possible. So you have to tell me, out of all of these possible substrings, how many are palindromes? For example, this entire string is a palindrome, right? But if you check this substring, CEC, this is also a palindrome. If you check this entire substring, this is also a palindrome. So you have to tell me how many possible palindromes can you find out? So let us look at some of the sample test cases now. In the first test case, I have a string ABC. You can see that there is no palindrome possible in it. But there is a catch. You can have a palindrome that consists of only one character, because a single character is also a palindrome. So for this particular test case, your answer will be indeed 3, because you have 3 characters possible that are palindromes in itself. So you just have to return me this number. You don't have to tell me the strings possible. Let us move on and look at the second test case. If you see this test case, I have simply 3 characters A, and A. Now you may say that, hey, this is just one palindrome. And there can be also single characters as well. But for this particular test case, the answer will be 6. If you're wondering, what will these 6 palindromes be? They are gonna look something like this. For example, I will have all of the individual characters as palindrome itself, right? I know they are same, but this problem does not ask you to find the unique number of palindromes. It just tells you that give me the count of all the palindromes possible. So this substring is different, this substring is different, and this substring is different. Similarly, look at the other 2 palindromes, AA and AA. You may ask why I have 2 AAs. Well, that is because the first substring is from the first and the second character, and the second substring is from the second and the third character. So you have 2 different substrings possible. And that is why you have these 5 substrings that are palindromes. And the last palindrome is the entire sequence itself because it is a palindrome. So that is how you need to take care of all of these corner cases. Let us look at one more generic case now. I have this string available with me and I have to find out the total number of palindromic substrings. The answer to this particular test case will be 7. And if you try to write down all of these palindromes based upon what have we discussed, they will be, first will be the single character A, then B, then A, then C. So you have covered all of these characters one by one. That will always be true. Now, what other palindromes can you find out? You see that BB is another palindrome, and then ABBA is also another palindrome. So I get a total of 7 palindromic substrings that can be derived from this original given string. Now, if you feel that the problem statement is even more clear, feel free to stop the video right over here and take a stab at it once again. Otherwise, let us dive into the solution. Let's say you start off with this particular test case. Now, when you start to attack this problem, you will soon realize that a brute force solution is not even feasible. Because in a brute force solution, you will try to generate all the different possible substrings and then you will check whether each of them are palindromes or not. So initially, even finding out all of these substrings will take you a lot of time, and then checking whether they are a palindrome, it is gonna take even more time. So a brute force solution is simply ruled out of the way. So you will try to think, okay, how can I optimize it? And when you start to optimize, the first confusion that will come to your mind is, okay, where do I even start? Do I start from the beginning, or do I start from the end? Or do I need to start from the middle? Well, the good news is that you can start in both the directions. But even before we get there, first of all, we need to understand a basic difference between odd length palindromes and even length palindromes. Over here, if you see, I have a particular palindrome that has a length of 3, right? And this particular palindrome has a length of 4. So what is the difference between them? If you notice closely, when I am looking at the odd length palindrome, the middle element could be anything. And this string would still remain a palindrome. It can be B, C, D, X, anything at all. And this would still remain a palindrome. So it gives you one important piece of information. Whenever you are checking for odd length palindromes, you start from the middle element, but do not compare it to anything. You compare the next character and the previous character. And then you can keep on expanding your search in both the directions, right? Whereas when you look at even length palindromes, what do you see over here? In an even length palindrome, my middle lies somewhere over here. It is not pointing at any of the characters, right? So even these two characters, they should be the same. And that is very special about even length palindromes. Therefore, if you're looking for even length palindromes, you start from a position and look at the adjacent characters at the same time. If they are the same, only then you will expand your search. You cannot ignore the middle character. Whereas in an odd length palindrome, you can simply ignore the middle element totally. You might still be wondering, why do I need all of this information? I need to have a count of all of these palindromes, right? I do not have to check even or odd. But here is a catch. So let us say you take up the same sample test case again. And then we are going to find out how many palindromes are possible. To do this, what we are going to do is, we will start off with the first character. And then for every position, we are going to consider it as the centermost point. If we have found out the centermost point, we are going to look for odd length palindromes, and then we are going to look for even length palindromes. So once we find out this count, we find the total number of palindromes for each position that is available in the string. And we keep a count of it. We will keep on iterating through every character, and at the very end, we should get a count of all of the palindromes that were possible. So how will this algorithm actually look like? So over here, I am first of all starting with the very first position. So my current character is A. And if I am starting off with this position as my center element, how many odd length palindromes I can find out? If you remember, in an odd length palindrome, the center position does not matter at all. So you look at the next character B and the previous character. It does not exist, right? So they are not the same. You can stop right over here and say that I do not find any other odd length palindromes. But you did find one odd length palindrome, and that has the length of 1, right? So you only found one palindrome that has an odd length. So the count over here was 1. At the same time, for every position, you also need to find out the even length palindromes. If this is my center position, I cannot ignore it now. This character should be the same as the next character. Only then I will continue my search and find the even length palindromes. Right now, I see that these two characters are different. So, no other even length palindromes are possible. What did I find over here? I found one odd length palindrome and one even length palindrome. This makes the total count of palindromes to 1 right now. Let us move ahead now. And this time I'm looking at my next character, and that is B. You start to find out the odd length palindromes first. So I'm starting off with this particular position. You know that a single character can be a palindrome, so I can first of all safely write down a B over here, right? And now look for more palindromes. Go in the right direction and go in the left direction. B is not equal to A. That means you can stop over here. You will not find any other palindromes. So that's it. And I could only find one odd length palindrome over here. What about even length palindromes now? Look at this character. I cannot ignore it. So I compare this B with the next B available. I see that they both are same. So what does that mean? I found a palindrome. So I will simply find that, okay, I found a palindrome BB and that gives me one count. You should not stop over here because there can be even bigger palindromes. So next, what do you compare? Go ahead in the right direction and go back in the left direction. You see a next character A and a A again over here. That is same. So once again you found a palindrome. So I found out two palindromes over here. Can you go further? The next character is C, but on the left I do not have any other character, so that is where you stop. How many palindromes did I find out? I found out two possible palindromes. What is the total now? I found one odd length palindrome and two even length palindromes. That gives me a total of 3 palindromes. You add it to this count. So this tells me that up till now, I have found out a total of 4 palindromes. Similarly, you can start to move ahead and then you will look at the next character. The next character is B. Can you find an odd length palindrome? A single character is the palindrome available, so I find it. But if I try to go right and left, both of these characters are different. So I cannot find any other palindrome. I only have one odd length palindrome available. What about the even length now? If you see, I will start off with this character and try to compare it with the next one. B and A are not the same. That means I do not find any other even length palindromes over here. So I simply say that I have 0 even length palindromes available. For this particular position, I only found out one odd length palindrome that was available. So I add this 1 to my 4 and this updates my count. Similarly, what we're going to do is we will look at the next position, that is A. Once again, only one palindrome is possible over here. And then you will move ahead and find out for the character C. Once again, only one odd length palindrome is available over here. So you have 2 more palindromes available. This count gets updated and you finally return 7. If you notice, this was the expected answer of our given sample test case. So what did we do over here? We iterated through each of the characters. And for every character, you go in both the directions to find out odd length palindromes or even length palindromes. You keep a total count and then you aggregate all of them to find out the total number of palindromes that are possible. Notice that it will take care of every different possible combination. It does not uniquely identify the palindromes. And it also does not tell you what the palindrome is. If you need to keep a track of that, you will need to store that somewhere in a string. For this particular problem, the count is enough. And we will quickly do a dry run of the code to see how it works in action. On the left side of your screen, you will have the complete code to implement this solution. And on the right, I have this sample string available that is passed in as an input parameter to the function count substrings. If you notice, I have this count variable available over here that is eventually returned as the answer. So this will tell me how many total palindromic substrings are possible. But we need to calculate it, right? So we start a for loop, and this for loop is gonna iterate through every character. It starts from 0 and goes all the way up to the length of the string. So basically, I will have a pointer over here, and this is gonna traverse. And for each character, what do? I find the total number of palindromes with odd length, and then I will try to find out all the palindromes with even length. You add up all of them and then simply return the total count when your for loop ends. you also need to understand how you are counting these palindromes. What we have over here is a private method to count the palindromes. And it takes in three parameters: the string, a left pointer, and a right pointer. The idea over here is that you're gonna check if the character at the left pointer is same as the character at the right pointer. If they are the same, you can keep on expanding your search, right? If at any instance the character on the left is different from the character on the right, it simply means that this string is not a palindrome. So, how does it work when you are finding the palindromes with odd length? To find a generic case, let us assume that currently you are at the second position, right? Or the first position when it comes to zero-based indexing. This position is passed in from the value of I. So, when I'm looking at odd length palindromes, notice that for both left and right, I send in I, which means that I'm starting off with the center position. So, I know that the character at left and right, they will both be the same. I am pointing at B for both my left and the right. If they are the same, I am gonna increment the count and I will do left minus minus and right plus plus. So, for an odd length palindrome, I will now look at A and then I will now look at B. So, this holds true with what we discussed. It stops over here because A and B are not the same, and you found that okay, only one odd length palindrome was possible. Once again, the value of left and the value of right, they were both the same, so they pointed at B. You compared that, okay, they are the same character, so you found out one odd length palindrome and you incremented the count. Now you want to do left minus minus and right plus plus. So left becomes 0 and right becomes 2. That means you're looking at A and B. Since they are not the same, you will stop over here and this particular while loop ends. Now is the time that you find out all the palindromes with even length. This is where everything will suddenly make sense. Notice the parameters that I'm sending in. The value of left is I, so I send in 1 over here, and the value of right is I plus 1. So I sent in 2 over here. So when this particular method runs, you are now looking at the character B and you're looking at this character B. That means I'm looking at even length palindromes. You found out that okay, they both are same. So once again, you will increment this count. You found one even length palindrome. Next, you will do left minus minus and right plus plus. So left changes to 0 and right changes to 3. That means you're looking at A and then a A again. Since they both are same, you will increment your count and the count becomes 2. You again try to do a left minus minus, but that will change the value of left to minus 1. And that is how you know that, hey, this is where you stop. So you found out a total of 2 even length palindromes. This value is returned over here and you add this count to your global count. That means the total number of palindromic substrings that you're finding out. This loop will continue for every character at the very end, and therefore you will find out the total number of palindromic substrings in this particular variable count. The time complexity of this particular solution is order of n squared because it is possible that for every character available, you go in the left and right directions all the way up to the end. And the space complexity of this solution is order of 1 because you're not taking up any extra space to arrive at your solution. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, I just want to say that whenever you hear the word palindrome, by definition, it feels more intuitive that you start from the first element and the last element, and then you start comparing whether they are equal. But often in competitive programming, I have seen that you will find more success when you start from the middle and then try to expand all the way, because it gives you the opportunity to fail early. You can identify that, okay, this character does not match, and you can stop over there. Whereas if you're starting from the first and the last pointer, you could have to wait up till the very middle point to identify that this was not a palindrome. So just keep that in mind whenever you're tackling such problems. Do you know any other method by which we can optimize this problem even further? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such videos. Also, a huge shout out to all of the members who support my channel. You guys are the real rock stars and you keep me going as well. And don't forget, as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.